So hello everyone, let us solve today's GfG problem of the day, and the problem name is deletion and reverse in circular linked list. So let us read the problem statement. So you are given a circular linked list and the task is to delete the given node key in the circular linked list and reverse the circular linked list. So you will be given a key and you need to find the node with value equal to key and you need to delete that node, and after that you need to reverse the circular linked list. Now in the end you just need to return the head of the linked list whatever modifications you have done. So let us see this first example and try to understand the question and find some solution out of it. So this is the example that they have given and the key here is 8. So that means we need to find the node with value 8 and we need to delete that node. So in this linked list this is the node that we want to delete. So how we can do that? So whenever there is a linked list question, it is all the game of pointers. So how you manage the pointers, how you handle these pointers, with the help of these pointers only you can solve the linked list question. So let us see how with the help of pointers we will solve the deletion part first. So first we are discussing for the deletion part, then we will see for the reversing part. So one thing is for sure, we need one pointer to traverse the linked list and to find this particular node. So let's say we are iterating with the help of current pointer. So we will go till node with value 8. So let's say current. So now current is at 8. Now we cannot simply delete this node. Why? If we delete this node, our situation of linked list would become something like that. 10. And here is the value 8. Now after deleting this, this would be pointing to head and 7 is pointing to here. So after we delete this particular node, this 7 will point to some garbage value, but we don't want this. We want 7 to be pointing to 10. So what we need to do? We need to handle the node which we are deleting, its previous node. So node which we are deleting, we need to handle the node which is just previous to that. So we need one another pointer. Let's say we name that previous. So this previous will keep track of the node which we are deleting, just a node before that. So here it is 7. So it will help us to change this link of 7 from 8 to 10 and then we can delete this node. So what we can do? So when we reach our position which we want to delete, so what we can do at that point? So we can say previous next should be pointing to current's next. Then we can say simply delete the current pointer. So we can say delete current. So these two operations we need to perform. So what will happen after we perform this operation? Let's say we are currently at here. So let me just erase this. So here 8 is present, 7 is pointing to it, and yeah, we are currently here. So according to this first line, what will happen? Previous next would be pointing to current's next. So previous next is this, should point to current's next. Current's next is 10. So we want previous next to point to 10. Okay. So we can remove this particular link. So yeah. And now what we are saying, delete this current node. So current is 8. So we can delete this 8, and if the node is deleted, its next pointer will also get deleted. So this is what we want to achieve and we achieved. So with the help of these two line of code, we can achieve our deletion operation. Now there are various edge cases also, but we can handle them separately while we write the code. So we will not discuss here. Those edge cases are very basic, and if you understand this, we can solve those as edge cases with these two lines of code as well. So we will not discuss here. We will directly discuss in the code part. So let us now move on to the second part of the question, that is reversing the circular linked list. So for reversing a circular linked list, we can just simply understand how to reverse a singly linked list. If we understand how to reverse a singly linked list, we can apply the same logic to circular one, just with one additional step. that is changing our head's next pointer to the last one. So if you understand how to reverse a singly linked list, we can apply the same logic to circular one, and with one just additional step. So we will understand how to reverse the singly linked list in order to achieve our goal. So let us see now. So this is the singly linked list that we have, and we need to achieve this part. We need to achieve this. So after reversing, our linked list would look like this. So how we can do this? So again, linked list is just game of handling pointers. So one thing is for sure, we need one pointer just for traversing. So let's say we name it as current. Now this is the first node or the head node. So head node should be pointing to null. So okay, we will keep this thing in mind. Now if we are at 5, we know that 5's next pointer should be pointing to its previous one. 7's next pointer should be pointing to its previous one. 10's next pointer should also be pointing to its previous one. So if you observe one thing, all of their next pointer should be pointing to their previous node. So we will maintain one another pointer which will keep track of previous node of the current node. So 2 pointers we need to have till now. So initially, so let me remove all these connections. Yeah, so initially our previous will be pointing to null because our head should be pointing to null, as you can see. So current's next would be pointing to previous. So okay, current's next should be pointing to previous, that is null. So we need to remove this connection. Yes, so we have achieved so we have reversed this part. But wait, we just lost the track of our second part of the linked list. Now there is no way in which we can move this current pointer to this part of the linked list. So how we can do that? So if you observe one more thing here, we need to make another pointer here that will keep track of current's next pointer. Because think obviously, if we are removing this link to previous one, then obviously we can't reach to its next part. So we will make another pointer next which will be nothing but current's next. It will always be pointing to current's next, so that we don't lost this second part of the linked list. So let me just redraw it, and I'll tell you the simulation how we are reversing the linked list, and from the simulation only we can understand how we can reverse this entire thing with the help of code. So let us simulate the entire reversing of this singly linked list and understand it in more better way. Now till now we know that we will reverse the linked list with the help of these 3 pointers. So we will initialize previous to be null, current to be pointing to the head, and next we will not point to anything. We will see how we will handle this next pointer. So current is pointing to head and previous is null. So first what we need to do, the most important thing, we first can't remove this link to null, because then we will lose the track of this second half of the linked list. So first we need to handle the next pointer. So what next pointer will do? Next pointer will be nothing but pointing to current's next. So yeah, so next pointer will be here. Now we can say that we can remove this link, because now we don't have any tension. We can just point current to next, and we can't lose the track of our linked list. So what we can do? We can simply say that current's next should be pointing to previous. So current next should be pointing to previous. Now what is previous? Previous is null. So we can simply remove this and point it to null. Yeah, so 2 is pointing to null, or head is pointing to null. Now what we need to do? For our 5 nodes next pointer, 5 should point to previous. And what is its previous? Its previous is 2. And what is 2? 2 is current. So we need to make our previous pointer to point to our current pointer. So what we can say? Previous should now point to current, and obviously current will be pointing to 5 because we just need to now change the pointer of 5. So we can say current should point to now next. So this is what will happen. So let us do it, the steps what we have said till now. So we have done this step, we have done this step. So previous should be pointing to cur, okay, previous is here. Now current should be pointing to next, so current is here. So let us ignore this. So now again this step will happen until we reach the end of the linked list. So current's next should be next should be pointing to current's next. So we can remove this next and we can say next is here. Now remove this node link to its previous part, okay. So 5's link is broken. Now previous will be pointing to current, so previous will be here and we can remove the previous from here. Now current will be pointing to next, so current will be here and we can remove the current. So again 7's link will be broken and it will point to here. So it will keep on happening till the end of the linked list, but now you got it how we are reversing it. So with the help of this much of code we can reverse the entire linked list. Now similar logic is applied, but just one additional step, that in the end we just need to make our heads next to equal to the last node of the linked list for circular part. So in the code we will see how we will do it, but if you understand this part, it's exactly same for the circular as well. So this was it about the explanation of the deletion of a node and reversing the entire linked list. So let us write the code now and understand in more better way. So let us see the code now. So first we will see for the deletion part, then we will see for the reverse part. So first is the edge case that we have seen, that we will discuss in the code, that if head is equal to null, then simply return null. So this is one edge case. Another edge case can be if the node which we want to delete is the head node only. So if head data, it is data only, I think. Yes, it is data. So if head's data is equal to key, that means the node which we want to delete is the head node only. So we need to change the last pointer of the circular linked list to head's next pointer. So that is the edge case that we were talking about. So if the node which we want to delete is head, then again there is one more scenario. There are two scenarios actually. So if the head is the only node in the linked list, that means we just need to return null after deleting the head. So if head, so how we can check if head is the only node? So head's next should be also pointing to head only. So if head's next is equal to head, then simply delete head and simply return null, because there will be nothing left. But if head is not the only node in the linked list, that means we need to now change the last pointer of the circular linked list. So first we need to find what is the last pointer. So node star last will be pointing to head initially, and while last next does not become equal to head, not equal to head, we just keep moving our last pointer. So last equal to last next. Now we know what is the last position or last node of the circular linked list. Actually there is no last, it is in a circular way, but still you understand what I am saying. So what we need to change, we have seen that if we want to delete current node, we have the previous node and we have the what we do, we change previous next pointer to current's next. In this case our current is head, so we need to change our last next pointer. Previous in this case is last, so we need to change the last next pointer to head's next pointer. So we need to do that, and that is it about the edge case. So let us see how we'll do it. So last next is equal to head's next. So in this case our current is head and our previous element is last. So what we would do if there was a normal node that we wanted to delete, what we have seen in the explanation part, previous next is equal to current's next. So it is same thing, just our previous here is last and our current node here is head. So yes, now we need to delete this head node. So first we will store it in one temporary variable, temporary pointer. So temp equal to head. Now head equal to head next, because now our head node is deleted. So there will be a new head which will be assigned to our linked list. So head equal to head next. Now simply delete the head node and return the head node, but before that remove the temporary node. So delete temporary. So this was it about the edge case which we were talking about, and now just we need to implement the thing that we have seen in the drawing explanation. Now for the regular case, what we have seen, we will maintain two pointers, previous and current. So current will be pointing to the head of the linked list, and what we need to do, while our current's next does not become equal to head, we need to keep moving until we get our key value. So what will happen, previous will become current and current will become current's next. In between we might find one node whose data value is equal to key. So if current's next is equal to key, what we need to do, we need to remove the current, or we need to delete the current. So for that we have seen, first we will change the previous next pointer to current's next pointer, and then simply delete current and just return head from here. And in the end we can also return again head, otherwise it will give us error, return head. So yeah, this was it about the deletion part. So let us see now for the reverse of the circular linked list. So first is the edge case which we were talking about, if head equal to null, or if head next is equal to head. So if there is no node in the linked list, or if there is only single node in the linked list, then we don't need to reverse, simply return the head. If head would be null, it would be returning null. If head would be only the single node, it will just return the single node. So this was the edge case which we were talking about. Now how to reverse the circular linked list? We will define three pointers, previous which we initially to null, current which will be initially to head, and next which we will initialize afterwards. Now we need to reverse the circular linked list. So for that we will use a do while loop. Now why we are using a do while loop, I will tell you. So while current is not equal to head again, so for the circular part we have seen while current is not equal to null, but since it is a circular part, so we will write while current is not equal to head, because we need to change the head to the last part of the last node of the linked list again. So we'll write this. So why we are using a do while loop? So if we are simply using a while loop, so you can see that our current is initialized to head only. So this condition will be valid for the first step itself, so our while loop will not run. But if you know the property of do while loop, even if the condition is met, it will still run for the first time. And if our do while loop is running for the first time, obviously it will continue to run, because then this condition will only occur if we have reversed the entire circular linked list. So that's why we are using a do while loop. So while current is not equal to head, what we have seen, first next will be pointing to current's next, then what we have seen, current's next will be pointing to previous, then previous will be pointing to current, and current will be pointing to next. So this was the sequence that we have seen in our explanation part. Now the only thing remaining is to change the head's next pointer to the last node. So what is the last node? Last node would be previous only, because our current will be pointing to head. So previous node would be obviously the last node. So head next would be nothing but previous, so it will point to previous. And since we have reversed the entire linked list, this previous will now become our new head. So keep this thing in mind, so don't forget to write that. So head will be equal to previous, and in the end just return head. So this was it about the reverse part of the circular linked list. So let us submit this if this works fine or not. So it is giving us the error. So yeah, we have written wrong thing here. So not currents next equal to key, currents data, because we need to compare the value here. So by mistakenly I have written that. So if current data is equal to key, then remove the current node or delete the current node. So let us see if this works fine or not now. So yeah, our code got accepted. So hope you learned from this video, and yeah, don't go behind this accuracy, because I missed this thing to write the head equal to previous part, and yeah, I just keep on submitting by doing some changes, and yeah, I just keep on submitting and it just decreased my accuracy. So yeah, this was one thing that I wanted to share. So yeah, hope you learned from this video. Thank you.